Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will continue with the implementation of the queue. In our previous tutorial we discussed how to add an element in a queue in Java. So in this tutorial we will discuss how we can remove an element from a queue in Java. So friends, in my previous tutorial I added 3 elements into the queue by data as 10, 15 and 20. So in this tutorial, we will discuss how we can remove an element from a queue, which is nothing but a dequeue operation. So here I will take the same example and you can see that queue has 3 elements where front is pointing to the first node and rear is pointing to the last node and length is 3. So here you can see this is the algorithm for a dequeue operation. Now let's see the demonstration of this algorithm step by step. Now in the first step we will check that whether queue is empty or not. So currently if you see, length is 3 and we know that the queue contains 3 nodes, therefore queue is not empty. So the condition in if block comes out to be false. Now friends, as we want to remove an element from a queue, so here you can see the return type of dequeue method is integer type. We are actually removing an element from the queue and we are sending back the data part of it. So in order to store the data somewhere, we are creating an integer variable by name result and we are storing front.data into it. So friends, in my previous tutorial, we discussed that queue is a list with few restrictions where the elements are inserted at one end, which is the rear end, and elements are removed at one end, which is the front end. So friends, the restriction which we impose on a list makes it a queue, and therefore the queue is called as FIFO list, which is first in first out. So here you can see by first in first out we mean the element inserted first would be the first one to be removed. So in my previous tutorial we discussed when we inserted the elements into the queue, we inserted first 10, then we inserted 15 and then we inserted 20 using the rear end. Now in order to remove an element, we know that 10 was inserted first, so now 10 would be removed first. So this is nothing but a FIFO property, first in first out. So let's see how we can use the front end to remove the nodes which are inserted first. So here after this line gets executed, results hold the value of 10 because the node 10 was the node first inserted into the queue. Therefore this node will be removed first. Moving ahead. Now friends, in order to remove this node from the queue, we know that it is being referred by this front node. And if we break the link from front to this node, then this node can be removed easily. So in order to do that, what we are doing, we are simply assigning the value of front.next to front. So here we are simply assigning front next value to front, so that once this node is removed, 15 becomes our new front. So therefore we are simply assigning the value of front.next to front. So it would look something like this. Moving ahead. Then we are checking whether the front is equal to null or not. So currently you can see front is pointing to the second node, therefore it's not null. So the condition in if block comes out to be false. Moving ahead. So friends, as we have removed the reference of front from this node, therefore this node will be garbage collected, and you can see once this node is removed, we will decrement the length by 1. So currently the length is 3 and after the removal of this node, length becomes 2. So we simply decrement the length by 1. Moving ahead. And in the final step, we'll simply return the value stored in the result. So friends, when the dequeue method is executed, the queue has 2 elements and length is 2. Now friends, let's suppose we call dequeue method once again. So here first we check whether the queue is empty or not. So currently queue has 2 nodes, therefore it's not empty. And then we'll simply store front.data into the result. So it would look something like this, that we are storing the data into the list node which is being pointed by the front. So now result contains the value as 15. Moving ahead. Now in order to remove this node from a queue, we have to break this link, because if front is referring to this node, then this node would not be removed. So in order to break this link, we are simply assigning front.next value to front. So it would look something like this. Moving ahead. Then we are checking whether front is equal to null or not. So front is pointing to this third node, therefore it's not equal. So the condition in if block comes out to be false. And here, as we have removed the link of front to this node, so now this node has no reference to it, therefore it will be removed easily. We know that now Q has only one element, therefore we will decrement the length by 1. Moving ahead. And in the final step, we'll simply return the value stored in the result, which is 15. So friends, when the dequeue method is executed, queue has only one element where front and rear both point to that particular element, because this is the only element left. Now if we suppose call dequeue again, so first we'll check whether queue is empty or not. So currently queue has length 1, that means it has one node, therefore it's not empty. So the condition in if block comes out to be false. Then we'll simply store the value of front.data into result, because we want to return this value. So now result will hold the value as 20. Moving ahead. Now friends, we need to take an special care when we remove the last element from a queue, because if the queue contains only one element and if we want to remove that particular element, then we need to break two links. One is of front and other is of rear. Because if any of the link is referring to this node, then this node will not be removed. So therefore here we are simply assigning the value of front.next to front. So it would look something like this. So now front is assigned with its next value, which is null. Moving ahead. Now we'll check whether front is pointing to null or not. So currently if you see, front is pointing to null, therefore the condition in if block comes out to be true. And as we discussed that we need to break both the links in order to free this node. So therefore we'll simply assign the value of null to rear. So now this link will be removed. So it would look something like this. So now front and rear both are pointing to null. So friends, as this node is having no reference, therefore this node will be freed easily. So once this node is removed, we'll decrement the length by 1, because we know there are no elements left. So we'll simply decrement the value of length by 1. So now length becomes 0 because we have removed all the nodes. So in the final step, we'll simply return the value 20. So friends, once this method gets executed, this node gets freed up. And as we know that now front and rear both pointing to null, therefore the list is empty and length is 0. So friends, if we again call dequeue method, then the first step will check whether queue is empty or not. So here you can see front is pointing to null, rear is pointing to null, and we also know that length is 0, therefore queue is empty. So there are no elements left to be removed. So the condition in if block comes out to be true, and we'll simply throw in no such element exception, because there are no elements left to be removed. So friends, in this slide we discussed the demonstration of the dequeue method. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial I created one class by name queue. We created few instance variable of type list node, one of which was front and other was rear. We also created an integer variable which actually store the length of the queue. And then we have created few methods. One was length, is empty, and enqueue. So basically we created enqueue method which could insert the elements into the queue. And here if you see, and we also saw that we have added 3 elements, and when we printed the queue, it printed something like 10, 15, 20. So I will take the same list and will perform dequeue operation on it. So first let's write the dequeue method. So public, we know that the return type of it would be integer, so int dequeue. Now the first step we do is we check whether the queue is empty or not. So is empty. Now if the queue is empty, we know that there are no more elements left to be removed. Therefore we throw an exception as no such element exception, and we pass a string as queue is already empty. Moving ahead, now we know that when we remove an element from a queue, we are returning the data part of it. So therefore we'll create an integer variable by name result, and we'll store front data to it. Moving ahead, now as we have got the data of the front node, we'll simply traverse front to its next value by assigning front next to front, and then we simply check whether front is equal to null or not. So if front is equal to null, we know that we have to make rear also null, which we saw in the slide. Moving ahead, now as we have removed the node from a queue, we have to decrement the length by 1, and finally we are returning the result. So friend, this is the code for dequeue method whose demonstration we saw in the slide. Now let's test the working of this method. So initially we have inserted 3 nodes. Now let's say I dequeue one node, and then I print the queue again. So if I run the code, so you can see when we inserted 3 nodes, first 10 was inserted, then 15 got inserted, then 20 got inserted. So the insertion was at the rear end. Now when we are doing a dequeue, 10 was removed because we are removing a node from the other end, which is the front end. So thus queue is a FIFO list where we insert the node at one end, which is the rear end, and where we remove the node from the other end, which is the front end. So now as you can see, 10 was the first element to be inserted, therefore it got removed first. Now if I call dequeue again, so here you can see 15 also got removed, and if I call dequeue once again, so here you can see nothing got printed because we have removed all the elements from the queue. And when we printed the list, we can see when the list is empty, we are simply returning from the print method. So therefore nothing got printed. And now as list is empty, if I call dequeue one more time and if I run the code, we get an exception saying no such element exception as queue is already empty. So friend, this was the working of dequeue method. So friends, apart from this enqueue and dequeue method, queue also has 2 more methods by name first and last. So when we call the first method, we get the value stored at the node which is being referred by front, and when we call the last method, we get the value stored in the list node which is being referred by the rear. So here we simply create public int first. So here first we simply check that whether queue is empty, because if queue is empty, then we know that front and rear both points to null. Therefore we check whether queue is empty or not. And after this check, we simply return value stored in the front. So we simply return front.data. And we also write one more method, say last, which is very similar. We'll first check whether the queue is empty or not. And if the queue is not empty, then we'll simply return rear.data. So friends, let's test the working of first and last method. So here I will just remove this thing. So we have inserted 3 nodes by value as 10, 15 and 20. So if I run the code, so you can see front is pointing to a node having data as 10 and rear is pointing to a node having data as 20. So if I simply print q dot first and q dot last, and if I run the code, so you see it printed 10 and 20 because 10 is being referred by front and 20 is being referred by rear. So friends, in this tutorial we discussed about the dequeue operation. We discussed about the few of the methods like first and last. So this was basically all about the implementation of queue. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.